Welcome to Crisis in Perception, where we examine the systems shaping our world. I want you to just take a second and look at your window right now.
Depending on where you are, it might be raining, right?
Yeah, exactly. Or maybe the leaves are changing color, or, maybe you're dealing with one of those bizarre, unseasonal heat waves. Whatever it is you're looking at, I want you to ask yourself a question. Do you think of that weather or that changing of the seasons as an Earth problem?
Or do you think of it as a solar system problem?
Right. Because it sounds like a strange distinction, but it is actually, it's arguably the most important conceptual leap a person can make.
It really is.
Right.
Because if you are like the vast majority of human beings living right now, you probably treat this planet as a closed loop.
We absolutely do. We have this massive tendency to view Earth as a self-contained little blue marble. Just floating in the void where everything that matters, our climate, our geology, our history, happens strictly below the clouds.
But what if the rain hitting your roof, or the length of your calendar year, and the very fact that you have solid, stable ground to walk on, what if all of that is the direct ongoing result of invisible forces and violent histories happening millions of miles away?
And that right there is the core of what we're doing today. We are dealing with a deeply ingrained bias.
Yes, something you could accurately describe as a crisis in perception.
A crisis in perception. I love that framing because, evolution wired us to look at our immediate surroundings, right? We look at the soil, we look at the oceans, the local weather patterns, and we try to solve our problems by only analyzing those local variables.
Which is fundamentally flawed physics. Earth is not a separate entity from its cosmic environment. It is a direct outcome of it.
An outcome.
Exactly. You cannot divorce the biological and climatic stability we experience here from the gravitational architecture of the giant planets or the thermal radiation of our local star. The design of the solar system matters because planets do not simply exist beside one another.
They interact.
They do. Through gravitational relationships, radiation exposure, collision histories, Earth is not separate from its surroundings.
And curing that crisis in perception is the entire mission of this deep dive. Today, we are pulling from the brilliant insights in a book called Wonders of the Solar System. It's by Professor Brian Cox and Andrew Cohen.
It's a fantastic systems-level examination.
It really is. And our goal today is to completely reorganize how you perceive the world you are standing on. We're going to build the case piece by piece that Earth is just one node in a massive, interconnected physical system.
Which requires us, I think, to fundamentally reevaluate what space exploration actually represents.
Oh, absolutely. Because there is this pervasive habit in our culture. I mean, we all do it to view space exploration as a luxury.
A spectacle.
Right. We see the dramatic rocket launches, we see the nationalist posturing, the cinematic adventure stories, and we just file it all under spectacle.
But treating the space program as mere symbolism misses the point entirely. The exploration of our solar system is a vital knowledge system.
It really is the only mechanism we have to achieve structural clarity about our own survival.
Because if you only study Earth to understand Earth, you are trying to understand the rules of a complex game by only looking at a single playing piece.
You have to see the whole board. And to really understand how we started to see that board, I want to rewind the clock to a very specific moment. We need to go back to the exact day humanity finally broke out of that closed-loop, Earth-centric mindset.
January 2nd, 1959.
Yes. Picture this. It's the day after New Year's, a freezing winter afternoon at the Baikonur Cosmodrome. This is a super remote launch facility sitting out in the desolate steppes east of the Aral Sea.
A very harsh environment.
Incredibly harsh. And this massive R-7 rocket ignites. It's carrying a tiny spherical payload named the first cosmic ship. It ascends into the January sky, vibrating with hundreds of thousands of pounds of thrust. And just minutes into its flight, it does something that no physical object in the multi-billion-year history of this planet had ever done.
It hit a velocity of 11.2 kilometers per second.
11.2 kilometers per second, which is
escape velocity. The threshold required to permanently sever the gravitational tether of planet Earth.
Right, because think about it. If you throw a baseball into the air, gravity pulls it back down. If you shoot a bullet, it goes further, sure, but it still eventually falls back to the dirt.
Even the early satellites we launched, like Sputnik, were just falling in a circle around the Earth. They were still trapped in the planet's gravity well.
But this little sphere, which was eventually renamed Luna 1, it moved so incredibly fast that Earth's gravity simply could not pull it back.
The physics of that moment are profound. By achieving that specific kinetic energy, Luna 1 didn't just leave the atmosphere. It effectively transitioned its allegiance from Earth to the sun.
Which is wild to think about. On January 4th, it flew past our moon and coasted out into the interplanetary void.
And it eventually settled into a 450-day orbit between Earth and Mars.
Which means humanity literally manufactured a new tiny planet and added it to the solar system.
We did.
And it's still out there right now. It is humanity's oldest artificial planet, just quietly looping the sun.
It acts as the ultimate vanguard. And when you consider the scale of the armada that followed it, in less than a single human lifetime, mind you.
Yeah, the progress was explosive.
It was. In the decades since Luna 1, we have sent dozens of robotic emissaries and 21 human explorers beyond the bounds of Earth orbit.
We even have 5 spacecraft, the Voyagers, the Pioneers, and New Horizons, that achieved an even more extreme threshold.
Solar escape velocity.
Exactly. They are permanently leaving the sun's gravitational embrace, heading out into the interstellar medium.
They're leaving the system entirely.
I still remember the first time I saw the images Voyager 1 sent back in the late 70s, specifically that false color close-up of Jupiter's Great Red Spot.
An iconic image.
It wasn't just a dot in a telescope anymore. It was this churning, mesmerizing swirl of deep reds and brilliant blues, a hurricane the size of multiple Earths that has been raging for centuries. It just felt like art and science colliding.
It did. But it's important to recognize that it was more than just inspiration.
Right. And I want to push on something you mentioned earlier. You called this exploration a knowledge system for our own survival. How did sending a probe to photograph a storm on Jupiter actually help us back here on the ground?
It provided a radical shift in visibility. For the entirety of human history, we were trapped on the inside looking out.
Right, standing in a field looking up.
Exactly. When you look up from the ground, the sky appears infinite. The horizon seems boundless. That terrestrial perspective breeds a false sense of security. But when we sent machines and humans outward, and they turned their cameras back toward us, we gained the unprecedented ability to see Earth as a planetary body rather than merely a homeland.
The Apollo 8 Earthrise photo is the classic example of this.
It is, and for very good reason. Seeing the Earth rising over the dead, gray lunar landscape did more than document a successful mission. It reorganized human perception.
Because from 250,000 miles away, you don't see an infinite sky.
No. You see a fragile, incredibly thin envelope of atmosphere clinging to a rock in a hostile void. It visually proved that the systems supporting all biology are contingent and vulnerable.
And shared.
And shared, yes. In evolutionary terms, curiosity became a deeply adaptive trait for us. We had to physically leave our home to comprehend the fragility of the house we live in.
It's that old idea that a fish doesn't know what water is until you pull it out of the ocean. We had to get out of the atmosphere to understand what an atmosphere actually is.
Precisely.
And once we are out there, looking at the wider neighborhood, the first thing that becomes apparent is the sheer, unyielding structure of it all. The solar system isn't just a random scattering of rocks. It is governed by an incredibly strict physical incentive architecture.
Its incentive architecture is not human, but physical. Everything in our local cosmic environment obeys Sir Isaac Newton's laws of celestial mechanics.
Right. Human systems are governed by politics, economics, and motion, which are inherently chaotic.
But the solar system is governed by mass, gravity, and distance. Gravity organizes the motion. Mass shapes influence. Distance governs temperature and energy availability.
It is a giant interlocking piece of clockwork. And orbital regularity creates predictability. But the rhythms of this clockwork are deeply alien when you try to map them onto our standard human experience.
They really are.
We are so hardwired to a 24-hour day and a 365-day year that the tempos of the other planets feel like science fiction. Just look at the extremes. Mercury whips around the sun in a frantic 88 days, traveling at 200,000 kilometers per hour.
A very fast year.
But then you look at Venus. Venus takes 225 Earth days to complete one orbit around the sun, but its rotation on its own axis is so agonizingly slow that a single Venusian day from one sunrise to the next takes 243 Earth days.
Which means a day on Venus is literally longer than its year.
A day is longer than a year. That completely breaks the intuitive models we build from living on Earth.
It does. And as you move outward, the scale of this clockwork expands exponentially. Mars operates on a 687-day orbit. Jupiter takes 12 Earth years. Saturn takes nearly 30 years to make a single circuit. Uranus takes 84 years.
And then there is Neptune. Neptune takes 165 Earth years to complete one orbit. The book points out this incredible statistic. Humanity discovered Neptune in 1846. But because its orbit is so massive and agonizingly slow, it didn't complete a single full orbit since its discovery until the year 2011.
An entire planet taking a century and a half to make one lap around the sun.
It's just staggering.
It perfectly illustrates the temporal scale we're dealing with. But it is vital to remember that the elegant, predictable nature of this clockwork was not always obvious to us.
Oh, not at all.
In fact, for thousands of years, our ancestors were trapped in a profound crisis of perception regarding how this system actually functioned.
Right, because we assumed we were the center of it all, the geocentric model.
Yes.
And nothing highlights the absolute headache that model caused quite like the mystery of Mars. The ancient Greeks and astronomers going as far back as 1534 BCE spent centuries staring at Mars and pulling their hair out because of something called retrograde motion.
Retrograde motion is a fascinating historical blind spot.
Explain how it looked to them.
Well, if you track Mars across the night sky night after night for most of the year, it drifts in a predictable straight line against the background stars. But occasionally it does something that, to an ancient astronomer, seemed physically impossible.
It breaks the pattern.
It appears to slow down, stop, change direction, loop backward on its path for a few weeks, and then stop again before continuing on its original forward trajectory.
It basically traces a little loop-the-loop in the sky. Now, I want to pause here because this is fascinating to me. Why did it take humanity over 3 millennia to figure out what was actually causing that little loop?
Because of the foundational assumption they were starting from, our ancestors looked at the solid ground beneath their feet, felt no motion, and concluded that Earth was the immovable center of the universe.
Which feels like common sense when you're just standing in a field.
Exactly. But if you believe Earth is stationary, and you believe all celestial bodies must orbit us in perfect, divine circles, then the retrograde motion of Mars cannot be easily explained. A planet cannot just decide to fly backward.
So to fix the glitch, ancient astronomers had to invent increasingly absurd math.
They came up with the concept of epicycles.
Epicycles, right. They proposed that Mars wasn't just orbiting Earth in a big circle, but that it was also orbiting in a tiny little circle along that bigger circle, like a teacup ride at an amusement park.
It's a great analogy.
They just kept adding imaginary, invisible wheels within wheels to try and force the square peg of reality into the round hole of their Earth-centric worldview.
It was a monumental intellectual defense mechanism designed to preserve Earth's special status. The structural clarity we enjoy today only emerged once. Nicholas Copernicus, and later Kepler and Galileo, dared to shift the center of the model.
They had to break the geocentric illusion.
Once we accepted the heliocentric reality that the sun is the center and Earth is just another moving node in the network, the mystery of Mars vanished instantly.
Because it's just an optical illusion caused by two runners on a track. Earth is on the inside lane, closer to the sun, so we orbit faster than Mars. Every couple of years, we simply lap them.
Precisely. As Earth overtakes Mars on that inside track, our relative viewing angle changes. It is exactly the same visual effect you experience when you are driving on a highway and you speed past a slower car.
Right.
For a brief few seconds as you pass, the slower car appears to be moving backward relative to your position, even though both of you are driving forward.
It is such an elegant solution, but it required us to accept that we are passengers on a moving ship, not the center of the universe. And I think we still forget that reality today.
We do.
We get so caught up in our daily lives that we ignore the mechanics of the solar system until something happens that forces us to look up.
The authors point to a total solar eclipse as the most visceral, inescapable reminder of these mechanics. It is one of the few moments where the cosmic clockwork reaches down and touches human experience directly.
Anyone who has stood in the path of totality knows exactly what you mean. It is the middle of the afternoon, the sun is shining, and suddenly the temperature plummets.
The wind shifts.
The sky turns this eerie, deep twilight purple, and you look up to see a black hole punched in the sky where the sun should be. In that exact moment, you aren't just a person standing in a field. You are acutely aware that you are standing on a giant rock, and a slightly smaller rock just perfectly intersected the physical path between you and a burning star.
It is celestial mechanics made physical.
And once we deeply internalize that reality, that Earth is just one planet governed by the exact same universal laws of physics and thermodynamics as every other body in orbit, we unlock an incredibly powerful scientific tool.
The cosmic laboratory.
The cosmic laboratory. This is where the book's systems-level perspective really starts to blow my mind, because planetary comparison becomes one of the most powerful tools in science.
It does. Think about a climate scientist trying to understand how our atmosphere is going to react to rising carbon levels over the next century. If Earth is the only planet you ever study, your job is incredibly difficult.
You only have one data set.
Exactly. You are trying to predict the outcome of a massive, complex system with 0 points of comparison. But the solar system provides us with hundreds of other worlds.
And the foundational principle here is that the laws of chemistry and physics do not change just because you leave Earth's atmosphere.
The way radiation interacts with gases, the way heat is trapped or lost, the way atmospheric pressure alters boiling points, these mechanisms operate identically on Venus or Mars as they do here.
Therefore, Earth's finely tuned climate becomes infinitely easier to comprehend when we analyze it against the extreme failures of our immediate neighbors. Earth's climate is easier to understand when viewed against Venusian runaway heating and Martian atmospheric loss.
So let's look at those failures, starting with Venus. Venus helps clarify the greenhouse effect by showing what happens when atmospheric warming becomes extreme.
Venus is often referred to as Earth's twin, and structurally that makes sense. It's almost the exact same size, roughly the same mass, and made of the same rocky silicate material. It formed in the same general neighborhood of the solar system, just a little bit closer to the sun. But the reality on the surface of Venus is straight out of a nightmare.
The conditions are genuinely apocalyptic. The surface temperature on Venus rests consistently at over 460 degrees Celsius.
Hot enough to melt lead.
Yes, lead would flow as a liquid. The atmospheric pressure is staggering. Standing on the surface of Venus would feel like being 900 meters underwater on Earth.
You would crush a submarine.
The atmosphere is so thick and heavy it would crush a human instantly, and the cloud cover is laced with droplets of highly corrosive sulfuric acid.
But wait, if Venus and Earth formed from the exact same raw materials at roughly the same time, why did a few million miles of distance trigger such a drastically different fate? How does a planet turn into a pressure cooker?
It is the ultimate case study in the runaway greenhouse effect. Because Venus was closer to the sun, it received more baseline solar radiation.
Yeah.
Early in its history, Venus likely had liquid water, perhaps even oceans.
Really? Oceans on Venus?
Is very likely. But that extra heat caused surface water to evaporate at a higher rate. Water vapor is itself a potent greenhouse gas. So, as more water entered the atmosphere, it trapped more heat,
Which caused more evaporation.
which trapped even more heat.
A completely unchecked feedback loop. The oceans literally boiled themselves into the sky.
Exactly. And once the water was in the upper atmosphere, ultraviolet radiation from the sun broke the water molecules apart into hydrogen and oxygen. The light hydrogen escaped into space, meaning the water was lost forever.
And without oceans, the carbon cycle broke down.
Carbon dioxide baked out of the rocks and accumulated in the atmosphere, creating the crushing, superheated environment we see today. Venus provides absolute structural clarity regarding the dangers of an unchecked greenhouse effect. We literally test and tune our earthly climate models using data extracted from the Venusian atmosphere.
So when we look at that nightmare, it forces us to ask, why didn't that happen here? What stopped Earth from boiling its oceans away? The book highlights a mechanism that is so beautifully mundane we completely take it for granted. The rain outside your window.
On Earth, rain acts as a vital planetary scale chemical scrubber. As water droplets fall through the atmosphere, they dissolve carbon dioxide.
Turning into slightly acidic rain.
Right. The slightly acidic rain hits the rocks, weathers them, and washes that carbon down into the rivers and eventually the oceans, where it is locked away in carbonate rocks like limestone. The hydrological cycle on Earth is a geological thermostat. It regulates the amount of greenhouse gas in the atmosphere, preventing the kind of runaway thermal spiral that killed Venus.
It is wild to think that a rainy Tuesday afternoon is the literal mechanism keeping us from turning into a 400-degree molten wasteland. Okay, so Venus is the runaway furnace. What about Mars? Mars is the opposite extreme.
Mars helps reveal how fragile planetary habitability can be when atmospheric protection is lost. It sits further from the sun, but distance isn't the only reason. It is a frozen, desolate desert today. Mars is significantly smaller than Earth. It possesses only about 10% of Earth's mass.
And that single physical difference dictated its entire planetary destiny.
Yes, because smaller things cool down faster.
Like a cup of coffee cooling off faster than a large pot.
Precisely. Billions of years ago, Mars was warm, had a thick atmosphere, and we know for a fact it had flowing liquid water. We see the dried river deltas and lake beds carved into its surface, but because it was small, Its internal core cooled rapidly.
On Earth, we have a spinning molten iron core that acts as a planetary dynamo, generating a massive magnetic field that surrounds the globe.
A magnetic shield that blocks the solar wind.
Yes, the solar wind is a constant, violent stream of charged particles blasting out from the sun at incredible speeds. Earth's magnetic field deflects that radiation.
But when Mars' core cooled, its dynamo shut down. Its magnetic shield disappeared. And over hundreds of millions of years, the relentless solar wind literally stripped the Martian atmosphere away into space, molecule by molecule.
And without an atmosphere to provide pressure and trap heat, the liquid water either evaporated into space or froze solid into the permafrost. Mars shows us how incredibly fragile planetary habitability actually is. You lose your internal heat, you lose your shield, you lose your air, and you lose your oceans.
Venus choked on its own atmosphere, and Mars was stripped naked and froze.
It really contextualizes how narrow the margins of survival are for Earth. Earth's biological stability becomes more legible when placed in a system where most worlds are hostile to life.
It does. But there is one more world in this cosmic laboratory we must examine to truly appreciate how universal these physical processes are, and that is Titan.
Titan is wild. It's Saturn's largest moon, sitting over 1 billion kilometers away from the sun in the deep, dark freeze of the outer solar system. Surface temperatures there are hovering around minus 179 degrees Celsius. By all logic, it should just be a dead, silent sphere of ice.
Yet when the Cassini spacecraft and the Huygens probe peered beneath its thick orange smog, they found an environment that is eerily, structurally identical to Earth.
Titan is the only moon in the solar system with a dense atmosphere, but more importantly, it has an active flowing surface cycle.
The methane cycle.
This is the part that sounds like pure science fiction, but it's real chemistry. On Earth, we have the hydrological cycle. Water evaporates, forms clouds, rains down, carves rivers, and flows into oceans. On Titan, the exact same physical process is happening, but because it is so incredibly cold, the chemical actor isn't water. It's methane and ethane.
At those extreme sub-zero temperatures, water is frozen so solidly that it acts like bedrock. The mountains and canyon walls on Titan are made of water ice that is as hard as granite. But methane, which is a gas on Earth, exists as a liquid on Titan.
So you have actual rivers of liquid natural gas cutting through canyons of solid water ice, flowing into massive, dark lakes at the moon's poles.
Lakes with names like Kraken Mare, which is larger than the Caspian Sea.
There are clouds of methane, and it actually rains liquid methane on the surface.
The physical laws governing fluid dynamics, erosion, and atmospheric circulation are operating exactly as they do on Earth, just utilizing different chemical ingredients dictated by the distance from the sun.
Astrobiologists often refer to Titan as a deep freeze analog of the primordial Earth.
It is a snapshot of complex, prebiotic organic chemistry locked in a planetary deep freeze. Exploring Titan proves that the active shaping forces we see on Earth are not unique to our planet. There are systemic properties that emerge whenever a planetary body has an atmosphere and liquid on its surface.
So planetary comparison proves that our climate and atmosphere are governed by universal rules. But I want to pivot here, because the actual physical structure of the Earth, the rocks beneath our feet, the sheer volume of water in our oceans, that wasn't just randomly assigned to us.
It wasn't.
We have to look at the violent history of the system to understand where the Earth itself came from.
This is a crucial transition in our understanding of Earth as an outcome. If you look at the standard model of planetary formation, the inner solar system where Earth resides was incredibly hot. It was baked by the young, intense sun.
Any water present in the immediate vicinity of the forming Earth should have vaporized and been blown away.
Exactly. The early Earth formed as a relatively dry, barren, molten rock.
Which begs the massive question, if we formed as a dry rock, why is the Earth currently covered in a global ocean? Where did the water come from?
It was delivered to us by the sheer chaotic gravity of our giant neighbors. To understand this, we have to examine an event known as the Late Heavy Bombardment.
It sounds like an apocalyptic sci-fi movie, but it is one of the most important eras in our planet's history. About 500 million years after the Earth first coalesced, our planet and the Moon and Mars were suddenly subjected to an absolutely catastrophic onslaught of impacts.
The inner solar system was battered by millions of water-rich comets and icy asteroids.
If you look at the craters covering the Moon through a telescope today, you are looking at the scars of the Late Heavy Bombardment.
And why did millions of icy bodies suddenly dive bomb the inner solar system? We have to look outward to the orbital mechanics of the gas giants.
Right.
According to models like the NICE model, early in the solar system's history, Jupiter, Saturn, Uranus, and Neptune were orbiting in a much tighter, more compact configuration. But as they interacted gravitationally with the surrounding disk of debris, their orbits began to slowly migrate.
And when you have objects that massive shifting their weight around, the gravitational ripples are immense.
Eventually, Jupiter and Saturn hit a specific orbital resonance. For every 2 orbits Jupiter made, Saturn made exactly 1. This gravitational syncing acted like a cosmic pendulum being pushed at the exact right moment,
It amplified their gravitational influence.
violently destabilizing the orbits of Uranus and Neptune, pushing them outward into the primordial Kuiper belt, a vast ring of icy comets at the edge of the system.
It was like a bowling ball hitting the pins. The sudden gravitational chaos scattered millions of icy, water-rich comets. Some were ejected out into deep space, but millions of others were thrown inward, screaming toward the sun.
And Earth just happened to be in the crossfire.
The result of that violent, system-wide gravitational dance is that those impacting comets delivered a massive portion of the water that currently fills Earth's oceans. The water you drink, the water in your cells, is an ancient alien delivery brought here by the gravitational maneuvering of Jupiter and Saturn billions of years ago.
That is the ultimate proof that Earth is an open system. Without the gas giants violently shifting their orbits and throwing that ice at us, Earth might have remained a dry, sterile husk. We literally owe our oceans to the gravitational architecture of the outer solar system.
And we must recognize that this architectural dependence is not merely a historical footnote. It is an ongoing, active protection mechanism.
We are still tethered to Jupiter by invisible gravitational strings.
Because the universe isn't completely out of ammunition, there are still billions of colossal rocks and chunks of ice out there in the Oort cloud and the Kuiper belt. Every so often, one gets nudged out of its orbit and comes plummeting toward the inner solar system.
But Jupiter influences the architecture of the solar system through its immense gravity, altering trajectories of debris and affecting impact risk across inner planets.
It acts as a cosmic shield.
Yes, a cosmic vacuum cleaner, if you will. As comets or asteroids fall toward the Sun, Jupiter's gravity frequently alters their trajectories. It either slingshots them harmlessly out of the solar system, or it absorbs the impacts directly.
Like the Shoemaker-Levy 9 comet that slammed into Jupiter in 1994, we literally watched Jupiter take a bullet for the inner solar system.
The scars left in Jupiter's atmosphere from those impacts were the size of planet Earth.
If Jupiter wasn't there, sitting in the middle of the system and vacuuming up all that dangerous debris, the impact rate on Earth would be significantly higher, making long-term civilizational stability almost impossible.
We depend on the gas giants for our water, and we depend on them for our ongoing security. And we haven't even mentioned the most immediate gravitational tether we rely on, our own moon.
Right. The moon helps stabilize Earth's axial tilt, shaping long-term climatic regularity. The moon isn't just a pretty nightlight. Compared to other moons in the solar system, our moon is unusually large relative to the size of Earth.
And that massive chunk of rock orbiting us exerts a stabilizing gravitational pull on the Earth's equatorial bulge.
It functions as an anchor for Earth's axial tilt. Currently, Earth sits at a tilt of roughly 23.5 degrees, which gives us our predictable, moderate seasons.
Without the stabilizing gravity of that unusually large moon, the gravitational influences of the Sun and Jupiter would cause Earth to wobble chaotically on its axis over millions of years. The tilt could swing wildly from 0 degrees to 85 degrees.
Which would mean the poles could occasionally point directly at the sun, the ice caps would melt, the oceans would boil at the equator, and the climate would be thrown into violent, unpredictable extremes.
The development of complex, fragile ecosystems, let alone human agriculture and civilization, would be incredibly difficult, if not completely impossible, on a planet that wobbles like a dying top.
So again, the environment we enjoy is not self-contained. It is subsidized by the gravity of our neighbors.
Which brings us beautifully to the boundary condition that makes all this biological activity possible. The book refers to it as the thin blue line.
I love that phrase. When you synthesize everything we've just discussed, the runaway greenhouse of Venus, the stripped atmosphere of Mars, the deep freeze of Titan, the violent impacts from comets. The overwhelming takeaway is that the solar system is an incredibly hostile, inherently deadly environment.
It is.
Yet floating right in the middle of all that violence is Earth. And the only thing standing between the lush, living surface of our planet and the freezing, irradiated, airless vacuum of space is a flimsy, invisible envelope of gas.
It is a remarkable structural contrast. That thin atmosphere acts as a thermal blanket, trapping the warmth generated by the sun, while simultaneously acting as a shield, filtering out lethal ultraviolet radiation and incinerating millions of micrometeorites before they can reach the surface.
But to truly understand the dynamics of this planet, we have to look at what lies beneath that atmosphere. Earth is not a dead, static rock simply wearing a coat of air. It is a highly active geological
To
engine.
understand the Earth, we have to look down as much as we look out.
The authors point to the Grand Canyon as the ultimate physical evidence of this internal planetary engine. When you stand on the rim of the Grand Canyon, the sheer scale of it defies human comprehension.
It is vast.
It is 466 kilometers long, up to 29 kilometers wide, and over 1.6 kilometers deep. And it was carved out of solid rock by the relentless flow of a single river over the last 17 million years.
What makes the Grand Canyon scientifically profound is that the canyon walls function as an exposed physical timeline of planetary history.
As the Colorado River sliced downward, it exposed strata of rock that chronicle 2 billion years of geological time.
When you look at those layered bands of color, you are looking at the petrified evidence of ancient shallow seas, vast extinct deserts, tropical swamps, and ancient volcanic eruptions.
It proves that the surface of the Earth is in a constant dynamic state of renewal.
Precisely. Unlike the Moon or Mars, which are geologically dead and preserve craters for billions of years, Earth constantly erases its own history. The tectonic plates are constantly shifting, pushed by the massive convection currents of magma churning deep within the Earth's mantle.
That intense internal heat left over from the planet's violent formation and supplemented by radioactive decay is what drives the earthquakes, the volcanoes, and the shifting of the continents. Earth is alive because its core is hot.
And that hot core doesn't just push mountains around, it reaches all the way out into space to interact with the sun. This brings us to one of my favorite phenomena in the entire book, the aurora borealis, the northern lights.
The aurorae are the ultimate visual confirmation of our invisible tether to the solar system. We mentioned earlier that the sun is constantly blasting out the solar wind, a stream of highly charged electrons and protons.
When those high-energy particles slam into the Earth's magnetic field, which, remember, is generated by that spinning hot iron core, they're deflected. But the magnetic field lines funnel some of those charged particles down toward the north and south magnetic poles.
And when those solar particles hit the upper atmosphere, they collide with atoms of oxygen and nitrogen. The energy from the collision excites the atmospheric atoms, and as they calm back down, they release that energy as photons of light.
Oxygen produces those brilliant, ghostly greens and reds, while nitrogen gives off those vibrant blues and purples.
It is an incredible intersection of solar physics, planetary magnetism, and atmospheric chemistry.
But what is deeply poignant is how humans historically interpreted this interaction before we possessed the scientific framework to understand it.
The book mentions a beautiful myth from the Sami people, the indigenous populations of the far north in Scandinavia. For centuries, they watched these massive silent curtains of light shifting in the dark winter skies. They didn't know about solar wind or magnetic fields, so they conceptualized the aurorae through a deeply human, emotional lens.
The legend says that the lights are the spirits of women who died before they could have children, and their souls are trapped in a limbo between the frozen earthly landscape and heaven, condemned to dance eternally in the dark sky.
It is a mournful, poetic attempt to anthropomorphize space weather. It perfectly encapsulates the historical crisis in perception. We sought human terrestrial explanations for cosmic phenomena.
But the physical reality, that the lights are a visible manifestation of a magnetic force field protecting our atmosphere from the radioactive breath of a star 93 million miles away, is arguably even more beautiful.
And what's amazing is that this specific physical reaction isn't unique to Earth. The authors call them eerie echoes of physics occurring across the solar system. Because the laws of nature are universal, we see the exact same process happening on other worlds.
We do. Jupiter possesses a magnetic field roughly 20,000 times stronger than Earth's. When the Hubble Space Telescope focused on Jupiter's poles, it revealed permanent massive aurora ringing the planet. The exact same solar wind is interacting with a different magnetic field on a much grander scale.
Saturn also exhibits intense ultraviolet aurora at its poles. The mechanism is a universal fingerprint.
But the magnetic environment around Jupiter is so intense that it doesn't just interact with the sun, it interacts with its own moons.
And this leads us directly into a massive paradigm shift in planetary science. I want to talk about beyond the Goldilocks zone.
For a very long time, the scientific consensus regarding planetary habitability was strictly tied to distance from the sun.
The Goldilocks zone, the narrow band of orbital distance where it is not too hot for water to boil and not too cold for it to freeze solid. Earth sits perfectly in this zone.
We assume that if you travel out to the orbit of Jupiter, which is 5 times further from the sun than Earth, the solar energy drops to about 4% of what we receive. By all traditional logic, the moons of Jupiter should be entirely dead, frozen blocks of ice and rock.
But when we actually sent probes out there, the Voyager and Galileo spacecraft, they completely shattered that assumption. Let's look at Io, the innermost of Jupiter's 4 large Galilean moons.
Io is a relatively small moon out in the deep freeze.
It is too small to have retained its own internal heat from formation, and the sun is too distant to warm it. It should be a frozen, inert rock.
But instead, Io is the most violently volcanically active body in the entire solar system.
The visual data from Io is staggering. Its surface is a mottled, sulfurous yellow, pockmarked with vast lakes of molten lava. Spacecraft have photographed massive volcanic plumes shooting geysers of sulfur dioxide gas 300 kilometers high into the frigid vacuum of space.
The entire moon is essentially turning itself inside out through continuous, violent eruptions.
So we have to ask the obvious question. If the heat isn't coming from the sun, and it isn't leftover heat in the core, where on Earth, or where on Io, is the energy coming from to melt an entire moon's worth of solid rock?
The answer lies in the intense gravitational physics of the Jovian system, specifically a phenomenon known as tidal heating caused by orbital resonance.
Io orbits very close to Jupiter, so it experiences a massive gravitational pull from the gas giant.
But Io is also locked in a specific orbital resonance with its sister moons, Europa and Ganymede. For every 4 orbits Io makes, Europa makes exactly 2, and Ganymede makes exactly 1.
So they keep lining up.
Exactly. And every time they align, Europa and Ganymede exert their own gravitational tug on Io, pulling it slightly away from Jupiter. This constant gravitational tug-of-war forces Io's orbit to become slightly elliptical rather than perfectly circular.
Which means sometimes it is closer to Jupiter, and sometimes it is further away.
And because gravity weakens with distance, the tidal forces acting on Io fluctuate drastically. When Io is closer to Jupiter, the immense gravity literally stretches the moon, causing the solid rock of its crust to bulge outward by as much as 100 meters. When it moves further away, the bulge relaxes.
The moon is literally being squeezed and kneaded like a ball of dough by the gravity of the planets around it.
And just like if you take a piece of metal and bend it rapidly back and forth or rub your hands together really fast, that physical flexing creates immense internal friction.
The mechanical energy of that gravitational flexing is converted directly into thermal energy. The friction generates so much heat deep within the mantle of the moon that it melts the rock into magma, powering the apocalyptic volcanic displays on the surface.
It proves that massive amounts of energy can be generated by forces completely outside a planetary body, far beyond the traditional Goldilocks zone.
It is an incredible display of physics. But if Io is the moon of fire, the real prize of the outer solar system is its neighbor, the moon of ice and water. We have to talk about Europa.
Europa is, without exaggeration, perhaps the most tantalizing and important world in our solar system right now. Like Io, Europa is subjected to the same tidal, flexing, and orbital resonance, though to a slightly lesser degree because it is further out.
From the outside, Europa looks like a giant scratched cue ball. It is completely encased in a shell of highly reflective water ice.
But when planetary geologists started mapping the surface using the high-resolution images from the Galileo probe, they noticed something that didn't make sense.
The surface of Europa is covered in these long, dark, linear fractures and ridges. But when they mapped the older cracks, they realized they had drifted. The ice shell was not in the position it should have been based on gravitational models.
The surface was rotating at a slightly different, faster rate than the moon's rocky interior.
The implications of that observation are staggering. The only physical way the solid ice crust could be mechanically decoupled from the solid rock core, allowing it to slip and slide independently, is if there is a lubricating layer between them.
And that lubricating layer isn't oil, it's liquid water. The data confirms that beneath the miles-thick shell of frozen ice, Europa harbors a global subsurface ocean of liquid salt water.
And we aren't talking about a shallow puddle. Models suggest this ocean could be 100 kilometers deep.
To put that into perspective, Europa is slightly smaller than our moon. Yet because that ocean is so incredibly deep and covers the entire globe, Europa contains more than twice as much liquid water as all of Earth's oceans, lakes, and rivers combined.
The tidal friction from the orbital resonance provides just enough internal heat to keep that massive volume of water liquid, preventing it from freezing solid despite the moon's surface resting at minus 160 degrees Celsius.
Which brings us to the most exciting, paradigm-shifting question in modern science. Where there is liquid salt water and where there is internal heat, could there be life?
The book notes that we see these mysterious reddish-brown stains welling up through the cracks in Europa's ice. Could those be complex organics? Could they be the visible signs of a biological ecosystem?
It is entirely plausible within the parameters of biology as we understand them. We know that life does not strictly require sunlight. Deep at the bottom of Earth's oceans, along the mid-ocean ridges, we have discovered thriving ecosystems surrounding hydrothermal vents.
These are areas where superheated, mineral-rich water blasts out of the Earth's crust into the pitch-black ocean. Entire food webs of tube worms, crabs, and bacteria survive there entirely through chemosynthesis, processing the chemical energy from the planet's internal heat, completely cut off from the sun.
If the exact same geological processes are happening at the bottom of Europa's subsurface ocean, which the physics of tidal heating suggests is highly likely, why couldn't a similar ecosystem exist there right now?
It completely redefines where we look for life. You don't need to be sitting at the perfect distance from the sun if your gravity is churning your core into a heater.
The scientific community takes this potential so seriously that massive resources are being deployed to investigate. The sources note the anticipation of dedicated missions designed specifically to fly through the Jovian system, analyze the chemistry of the ice, use ice-penetrating radar to map the ocean depths, and search for the chemical signatures of habitability.
Which brings us to the philosophical climax of this entire deep dive. Everything we have talked about today, the runaway greenhouse of Venus, the lost atmosphere of Mars, the delivery of oceans by comets, the protective shield of Jupiter, and the hidden oceans of the outer solar system, all of it funnels toward one ultimate question. I'm going to ask you, the listener, directly. Are we alone in the universe?
It is arguably the most profound question a conscious species can ask. And the text breaks down the philosophical weight to the two potential answers, both of which are equally staggering in their implications.
Let's consider scenario A. We are the only life.
Suppose the emergence of life requires such an impossibly precise sequence of cosmological accidents. The exact right giant planets, the exact right impacts, the exact right moon, the perfect atmospheric balance, that it only happened once.
If there is no life in the subsurface oceans of Europa or Enceladus, no life on Mars, and perhaps no life anywhere else in the galaxy, then the value of planet Earth becomes infinite.
It makes us a singular anomaly, a single fragile island of biology, consciousness, and meaning in an entirely dead, mathematically silent void. If scenario A is true, the burden of survival rests entirely on us.
Yeah.
If we destroy our biosphere, the universe goes back to sleep forever.
A terrifying yet deeply clarifying pressure. But then we must consider scenario B. What if the universe is teeming with life?
What if the universal laws of chemistry dictate that wherever there is liquid water and an energy gradient like the hydrothermal vents of Europa biology inevitably emerges?
If life is a systemic outcome of planetary physics, then we are not alone. We are merely one small part of a vast cosmic community. We are one village situated amidst a billion continents, adrift in a sea of alien biology.
It makes you feel incredibly small, but also incredibly connected. But regardless of whether scenario A or scenario B is the ultimate truth, the authors draw a deeply beautiful conclusion. When you look at the complex machinery of the solar system, the true wonder isn't the rings of Saturn, or the great red spot of Jupiter, or the volcanoes of Io.
The true wonder is civilization itself.
It requires the absolute rarest combination of blind cosmological chance, violent gravitational architecture, and strict physical laws to produce a planetary environment stable enough to support biology over billions of years.
But it takes an even more miraculous leap for that biology to evolve into a civilization. A civilization that can build telescopes, understand the orbital resonance of invisible moons, calculate the escape velocity of a rocket, and actually look back out at the universe that birthed it.
We are quite literally the universe waking up and trying to figure out how its own clockwork functions.
And with that capability comes an unavoidable imperative. As the custodians of this highly specific, highly contingent planetary environment and endowed with evolved intelligence, we possess the terrifying power to either protect this rare oasis or to thoughtlessly destroy its atmospheric and ecological balance.
The overarching theme of the text is that perspective is our greatest tool for survival. When we cure the crisis in perception, when we stop viewing Earth as a closed system and start viewing it as a vulnerable node in a vast interconnected network, we gain the structural clarity required to make better choices about our long-term survival.
Space exploration isn't a distraction from Earth's problems, it is the literal prerequisite for understanding how to solve them.
To summarize the journey we've taken today, treating Earth as an isolated, self-contained unit is a fatal flaw in perception. We are deeply tethered to the gravitational and thermal dynamics of our solar system. Earth's biological stability, its water, and its climate are legible only because we can contrast them against the hostile margins around us.
The runaway greenhouse of Venus, the stripped deserts of Mars, the frozen methane rivers of Titan, and the tidal fires of Io.
The solar system is a vast cosmic laboratory, and space exploration is the vital tool we use to read the results of those ongoing experiments, feeding that knowledge back into our own civilizational management.
Looking at all this interconnected machinery, it makes you wonder about the long-term math of it all. We've established that the solar system's clockwork is not static. Over millions of years, orbits will slowly drift, the sun is aging, and as it exhausts its hydrogen fuel, it will slowly expand, eventually increasing its luminosity and pushing the Goldilocks zone further out into the solar system.
Earth's oceans will eventually face the same boiling fate as Venus if left entirely to nature.
So, if we manage to survive our own technological adolescence, will our descendants eventually have to graduate from merely observing the solar system to actively engineering it?
Engineering the solar system.
Imagine a civilization having to physically move Earth's orbit, using the gravity of captured asteroids just to keep our planet in the shifting habitable zone. Or perhaps altering the atmosphere of Mars to give humanity a second home.
It sounds like pure, unadulterated science fiction.
But then again, if you told an astronomer in 1958 that humanity was about to launch a metal sphere fast enough to permanently escape Earth's gravity, they would have called that science fiction too.
It is the ultimate logical extension of the civilizational imperative. A species that understands the physical constraints of its system might eventually learn how to reshape them.
A completely wild thought to end on. Thank you so much for taking this deep dive with us today. Curing the crisis in perception takes a willingness to look up and confront the terrifying scale of where we actually live, and we're thrilled you joined us for the ride. Just a reminder that this project is completely free and publicly accessible. If you'd like to support the time, the tools, and the deep research behind the show, please consider checking out our Patreon. Also, be sure to check out the mini explainer linked in the description for a quick visual recap of the physics and concepts we discussed today. Please like, subscribe, and drop a comment letting us know what books, topics, or wild cosmic mysteries you want us to explore next. Until next time, keep looking up, and remember how profoundly connected we really are.